Okay, so I have a user's drawing who was saying that they were trying to run a stock list, and at a certain main it would just stop. So basically their stock listing tag came from this pipe right here, starting at 6'4", it went 10'4", it went 4'4", and then it just dead ended and stopped right at this coupling. We went and looked at it, and the listing tags looked fine, nothing looked off or anything like that. So at that point, this is when you start to think, maybe something's wrong with my elevations, and we want to run a tool called walk model, or the WMD command. So this is what this video is for. Today we're going to run the WMD command and try to figure out what's wrong right at this coupling here. So first off, we want to make a 3D model. Now you'll notice that we have it's elevated to 18 foot 10 and a half at this pipe. We run across here, and then we have a slope that's running right around here. So we're going to slope this pipe down to a new elevation of 15 foot 8. So we're going to go from 18 foot 10 down to 15 foot 8, and we're going to use this pitch here to tell this swing that it's going to swing down, and it's going to pick it up over here and run across here. Now, right off the bat, the one thing I notice is we have elevated this pipe with the 18 foot 10, we have elevated this pipe with the 15 foot 8, but we've also forced a slope here. So initially my thought is, I don't know if you want to do that. This is where you might take advantage of using, like, say, if the pipe was right above each other, say this 3'6" piece was running right along here, then that's where you would use a computer generated riser nipple, right? So in this case, this is kind of similar. We're going from one elevation to a new elevation, but we're forcing the slope. We're not telling it to be computer generated. So initially, this is my thought right here, that maybe there's something wrong with this pitch, but let's figure it out, and let's try to use the walk model to make sure we're right when we do that. So I'm going to start the 3D command. So I'm going to type in S3D. I'm going to select this boundary, and I'll hit enter. This also happens if you start a calculation and it says it can't find sprinkler heads. Same thing. It's basically it can't get to a certain point. It gets to a certain point and it just can't go any further because the pipe is disconnected. So let's see what we have. I see all these pitches here. I'm going to isolate the hydro pipe layer. So I'm going to select hydro pipes as my current layer. Then I'll type in AF, and this helps me see the system a little bit better. I will orbit, and we'll look at and see what it looks like. And I know that the system starts here, so the original listing tag was starting in this general vicinity. We're going over, we're going to swing up with this pipe here, we're going to run across here, pitch down, and then run across here. And you can see there are some riser nipples where we're kick back the riser nipple so that it matches the pitch of the branch line. So everything looks fine. If I zoom in real tight here, everything looks fine. It looks like it's all connected and everything. So at this point, I'd say, okay, I don't know. It must be something else. Let's try to figure out what's going on. Now, one thing I didn't mention, I'm going to go back down to 2D here. One thing I didn't mention is one of the tricks that you can use to confirm that your elevations are correct are not only to place the orange elevation marker that mentions the 15 foot 8, but to also place another annotation marker on here to confirm that that's your correct elevation. And when I look at this, my pink or peach colored annotation confirms 15 foot 8, no problem. That says 15 foot 8, there's no problem there. This says 18 foot 10 and a half, no problem. This is 18 foot 10 and a half. So again, according to everything here, everything looks fine. But let's go back up to 3D and let's double check something here. So I'm going to select my boundary one more time. Whoops. And it goes up to 3D. Now there are a couple other issues here regarding the drops being a standard length, because drop window wasn't placed, so it just assumes a 1 foot length, so that's fine. We're not going to worry about that too much. Same here goes for the sprigs. We assume that it's a 1 foot sprig because there isn't a sprig window. No big deal. I don't see any other errors in here, so far so good. But let's take advantage of the walk model tool. So I'm going to type in the command WMD for walk model, and I don't need to know any pipes that have no length, in this case anyway. I don't need to find pipes with no diameter. I don't need to find unknown fitting types. I just want to find out where my dead ends are, where caps are. The other thing I'm going to do is I'm going to basically tell it to walk in both directions. You'll see what this means in a second here. When I click proceed, it's going to ask me to select a pipe. Now there are going to be times where you're going to need to tell it to start from one direction and only go in one direction at one time. That's where you would select pick and from the end that you pick. But in this case, we're going to just walk in both directions and we'll go from there. So I'm going to click proceed. And I'm going to tell it to start walking from this pipe. And it doesn't matter which end I pick because I'm telling it to walk in either direction. But if I did tell it to only walk in one direction, I would want to start from this end. That means it would start at this end point right here and then walk in this direction and go over here. So that's all there is to it. So I'm going to select this pipe and tell it walk through the whole system. And what this will do is it's going to find all of the dead-ended pipe. Now what you're hoping for is you're hoping to make sure that all your pipe is turned blue, which it does. I can see here that all of my pipe has turned blue. I'm going to type in PF and turn off my slopes. And all my pipe is blue, and it is highlighting every cap on the system. Now this makes sense because that's a cap, it stops there and it found a cap, so that's fine. This is another cap right here. It is finding something right about here, and I have a feeling there might be something up with that rising nipple, but again, like I said, our issue was way over here, so we'll get to that in a minute here. So anyway, I'm gonna go back to a top view of this. And I'm going to look through here, and basically all of these caps I can ignore. Anything along the end here I can ignore. This, there might be something going on here. There's definitely something going on here, because right here you can see this is a cap. We can ignore that. I can even delete these as I find them. Let's try to click that again and delete it. But right here, I might want to go and investigate and see what's going on. Right here, I might want to investigate it and see what's going on, because there's something definitely telling it, hey, these two pipes don't meet, or there's a dead end here, and that definitely doesn't look like there should be a dead end here. But let's go back to our pipe in question. Like I mentioned, it was this coupling right here, right about here. And what's interesting is I had run this earlier and it definitely gave me this circle right at this location. So it's funny how the second time through it's giving me the error at a different location, but I can still show you what's going on here. So it's not cooperating with me fully, but we can still definitely see that something's going on, because again, even here these two pipes should be at the same elevation. So this is what we're going to do. I'm going to change my view to an isometric view so you can see what's happening a little bit better. And it's telling us that there's a dead end right here. Now, if I hover over one pipe, it's going to tell us the elevation is 15 foot 7 and 7/8. So that looks, I guess we'll have to trust that that is 15 foot 8. It's going to round to 15 foot 8. But let's take a look at this one right here. This one's coming back as 15 foot 7 and 3/4. So there's literally an 1/8 of an inch difference between these two pipes. Unfortunately, because of rounding, we couldn't tell that earlier, but because this is trying to be a little bit more precise, you can kind of even see it where this one pipe ends and this pipe ends here. They're not touching, they're not end to end. So this elevation change is what's causing the problem here. The 15 foot 7 and 3/4 and the 15 foot 7 and 7/8. There's an 1/8 of an inch difference between these two pipes, and that's enough for it to not recognize the pipe. Now let me go back here, because this is where I saw the problem earlier. 18 foot 10.5 versus 18 foot 10.5. So it's interesting how each time I run the process through, it changes the location, because like I said last time, this error message was showing up right here, and the 1/8 of an inch difference was right in these two pipes. But in this second run through, it's working fine. Now, like I had said, this end user forced the slope right here. And what they're doing is they're telling it, okay, no problem, go 18 foot 10. We're going to pitch it at the pitch that you told me to pitch it at. We're going to run across, and as soon as we have a break in the pipe, like a coupling, I'm going to readjust my value. And that's what's happening right at this coupling right here. And when we go back down to 2D, we'll see that happening. So this is the walk model tool. This is how to tell it to find caps and or find dead ends, and this is how you can track them down. Like I said, there are some other locations where we would probably want to double check. I think this cap is actually the cap at the end of the main here, so we can ignore that. But a top view is usually very helpful to track these down, and then you can erase them as you find them. So that's fine, that's fine, that's fine, that's fine, and then we just delete them and go until you track down where your dead end is. So let's go back down to 2D and let's fix this pitch. And what we'll do is we'll tell it that it's a computer generated pitch, not a user specified pitch. So I'm going to go back down to 2D. So show 2D. And we're going to go here, and you see this is where our coupling is. This is where it's telling us that we had a dead end pipe here, or a cap was found here. So again, that's where we had our 1/8 inch elevation change, or 1/8 inch elevation difference. And we're going to fix that. And all we have to do, I'm going to go back to the sloping pipe tool, and I'm going to erase this. Now this was set up as an 8 1/4 pitch over 12 inches. We're forcing it. We're telling it, give me a user specified pitch here. I don't want that. I want a computer generated pitch. So I'm going to go here to tell it computer generated. It doesn't matter which is the high end or low end. The computer will figure that out for us, and I'll just tell it to pick the finding points, and I'm going to go from this end right here to this end right here. I'll pick on that. I'll exit, and let's make a 3D model. Okay, I will walk the model, so WMD. I'll tell it to I'll uncheck all and tell it to find dead ends, and I'll proceed, and I'll tell it to start from this end right here, this pipe right here. And if I hit exit, I lose all of my blue pipe, so I'm not going to hit exit. I'll wait until I'm done, and let's go back to a top view here, and let's see. Let's flip it or spin it or rotate it. And let's go back here and let's see what happens. And there we go. We don't have any dead ends on. Like I said, the first time around was this coupling showed the dead end. This second time with you guys, this coupling here was showing the dead end. Neither of them have the dead end. And if I hover over these pipes, if I hover over this pipe, we're going to see the elevation is 15, 7 3/4. And this pipe should be 15, 7 3/4. It is. So these two are showing the same elevation. This is going to show 15, 7 3/4. This pipe will show 18 foot 10 1/2, and this pipe here will show 18 foot 10 1/2. So I think we're good. So this is how we were able to use the walk model tool to fix that. Now there was also a pitch over here where we would probably want to fix that as well. We would tell it, give me a computer generated pitch, and we'd fix it. But you can see that, especially for a grid system, it might be difficult to figure out what's going on and why it's giving you dead ends where there shouldn't be. And as you saw, an 1/8 of an inch will make that difference. So again, if you're having problems with calculations saying that it can't find flowing sprinkler heads, if you're having a problem with a list where it just stops at a certain point and it just won't go any further, you want to make sure that you go up to 3D, walk the model, and find your dead ends. Hope this video has helped, and thank you for watching. Take care. So I want to add something that I noticed when I was editing my video yesterday. If you had noticed that when we had finished up with this pipe, instead of it being actually at the elevation of 15 foot 8, it was coming back as 15 foot 7 3/4 or 7 7/8 or something like that. And that should have been enough for me to recognize, wait a second, it should be 15.8 on the dot. It shouldn't be off by 1/4 inch or an 1/8 of an inch or whatever. So I came back into the drawing and I started looking around, and I had noticed something that I touched on briefly, but I didn't really address. So yesterday we had deleted this slope and made it a 0, 0 slope to be computer generated, and I briefly said that, oh yeah, this slope is also should have been 0, 0, but it wasn't, and I just kind of left it as it was, and then we continued on, and then we got this one side to kind of work or still list. But here's one more tool that I want to make sure that you're aware of so that we can see it. So let me start over again by putting another annotation def line on here. So I'm going to type in AFF at the command prompt. I'll make sure to set it to be annotation. It's an off the floor. I'll pick insert. I'll drop one right here. I'll drop one right here. I'll drop one down here. and I'll drop a fourth one over here. Okay, so everything's all set. This is a much less severe pitch, but it's pitched nonetheless, but it's also a user-defined pitch. And we're going to want to swap this out to be a computer-generated pitch in a second. So let's reset this one as well. I'm going to delete this, and I will turn on my slopes. So I'll tell it that I want to go to my sloping pipe, 0, 0, computer-generated, and actually computer generated, and it disables these boxes. I'll pick my area, I'll select right here, and I'll select right here, and we are good to go. So I'll exit out of this, and we can see that we have our 0, 0 def line at this location. So everything's good to go pretty much. And let's make a 3D model here. So I'm going to S3D, I'll select my boundary, I'll hit enter. And again, we're getting the same messages about our drops and sprigs. I'll just tell it that I want to delete all typical errors like this. So I'll just tell it to delete all like this, 14 of those. And the PDF, I'll delete all like that. And then the sprigs, same thing. So I've just deleted all those error messages. And again, I hover over this, and it's coming back as 15.7 3/4, and it should have been 15.8 based off this def line. Now, I want to show you another tool where we can ask the computer, hey, you know what, how are you elevating this pipe? Which def line are you using to elevate this pipe? And that's the FDEF command. So I'll type in FDEF. I'll select this pipe, and I expect it to highlight the def line that was on our pipe. And you'll notice it doesn't use that def line. It gives me this construction line, or this interference line, and it's drawing it all the way over to here. So it's actually telling us that, hey, I didn't elevate this pipe off of the 15-foot AFF that you used. I elevated it off of this. So now we can see that, wait a second, something's up here. And long story short, what's happening is it's basically taking the elevation of here, using this pipe, going up, going back over around, coming back up around this side, going back over around, and then it's elevating and then going down the rise nipple, and then it's elevating this pipe based off this def line. But we really want this pipe to be elevated off of this def line here, or the orange one that we should have been seeing over here. And the reason why it didn't give us an error message is because it's close enough that it falls within the tolerance of, I think, a ½ inch. It says, okay, I'm not going to bother flagging that as another error because you're close enough. But really, we want this pipe to be using this, the orange def line that's supposed to be showing up here. We want it to be using it there. So let's go deal with that. So, and like I mentioned yesterday, or in my other video, we had another def line here, a pitch that we want, it should be a computer generated pitch, and it isn't. So let's go fix that, and let's see if that fixes everything here. So I'm going to go back down to 2D, S2D, and you can see here that this is where it drew the def line. So again, it should have drawn a def line from this, the midpoint of this pipe, to this orange tick, and it didn't. It drew the orange, the FDEF line over to this elevation marker. So already, again, we know there's something up here. So I'm going to delete that. I will turn off the, I'm going to PF on my that, and then I'm going to erase this def line, and I'll draw a new pitch, 0, 0 from here, from this end to this end. You notice I'm not going right to endpoint. I'm not shift right clicking and picking endpoint. It knows to go to the closest endpoint. So I'm not hovering here, the north side of that takeout. I'm hovering on the south end of that takeout. And there we go. I'll hit exit. I'll raise to 3D, S3D. All right, and then let's go check this one out. So if I hover over this pipe now, there it is. It's exactly 15'8". So perfect. It is actually giving us the exact elevation that we're looking for there. And if I do the FDEF command and I select this pipe, you can see it drew a def line and told me that I'm using this 15'8". And we can even see it's up elevated as well. So it is using the proper value. So I think we're in good shape here. So it's using the def lines it's supposed to be using. Let's just check this pipe here, FDEF, and select this pipe, and you can see it is using the proper elevation. So again, minor issues, but you can see how it can cause major problems later on. So you drew the pitch as user defined when it would have worked perfectly if you just drew it as computer generated, and I just want to stress that. All right, hope this helps, and again, thanks for watching.